March 19th, 1945. 0600 hours. The west bank of the Rhine River, near Remagen, Germany. Lieutenant Colonel David Gruber stood at the edge of a crater that had been a road intersection 12 hours earlier. German artillery had found the range during the night. 3 shells had landed within 50 meters of each other, turning packed earth and gravel into a moonscape of churned mud and shattered stone. Behind him, a convoy of 37 vehicles sat waiting. Sherman tanks, fuel trucks, ammunition carriers, medical supplies, everything the bridgehead across the Rhine needed to survive. The crater blocked the only route forward. Gruber commanded the 1146th Engineer Combat Group, part of the massive American engineering force supporting the Allied advance into Germany. His men had been working for 72 hours straight, sleeping in shifts of 90 minutes when they could manage it at all. They had built Bailey bridges across streams, cleared rubble from bombed villages, filled shell holes in roads that German artillery destroyed faster than Americans could repair them. Now this. Another crater. Another delay. Another calculation of how long it would take to fill, how many trucks would back up, how many soldiers at the bridgehead would run low on ammunition while waiting. Gruber made his assessment. The crater was roughly 8 meters wide, 4 meters deep. Standard procedure called for bulldozers to push debris from the edges, dump trucks to haul fill material, graders to level the surface. Properly done, the repair would take 4 hours. The convoy could not wait 4 hours. The bridgehead could not wait 4 hours. He gave the order. His engineers brought up a bulldozer and began pushing rubble directly into the crater without sorting or grading. They laid steel matting over the uneven fill. The surface was rough, unsuitable for sustained heavy traffic, but passable. The convoy rolled forward 47 minutes after the shells had landed. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This was American military engineering in the spring of 1945. Speed over perfection, functionality over elegance. Get it done now, improve it later if time permits. The philosophy had evolved through years of combat across North Africa, Sicily, Italy, France, and now Germany. American engineers had learned that in mobile warfare, a road that worked today mattered more than a perfect road that would be ready next week. German engineers operated under different assumptions. German military engineering emphasized permanent construction, precise specifications, thorough preparation. A German engineer officer surveying the same crater would have ordered proper excavation of damaged material, compacted fill layers, drainage considerations, a finished surface suitable for sustained use. The German repair would have been superior in quality. It also would have taken 8 hours instead of 47 minutes. This philosophical difference had consequences that extended far beyond individual crater repairs. As Allied forces pushed deeper into Germany in early 1945, they encountered a transportation network that German forces had systematically destroyed. Bridges were demolished. Rail lines were severed. Roads were cratered by artillery and air attacks, then further damaged by retreating German units who mined intersections and destroyed culverts. The Allied advance depended entirely on the ability of American engineers to rebuild this shattered infrastructure faster than combat operations consumed supplies. Every division advancing into Germany required approximately 700 tons of supplies daily: fuel, ammunition, food, medical supplies, spare parts. That tonnage had to move forward continuously, or operations would halt. The mathematics were unforgiving. An armoured division could advance 30 kilometres in a day against light resistance. Its supply trucks, travelling the same roads, could cover that distance in an hour. But if those roads were destroyed, if bridges were down, if routes were blocked, the trucks stopped. And when trucks stopped, tanks stopped. Not from enemy action, but from empty fuel tanks and depleted ammunition racks. German commanders understood this calculation. Their defensive strategy in early 1945 explicitly targeted Allied logistics. Every bridge demolished created delay. Every road cratered slowed the advance. Every rail line cut forced supplies onto already overburdened truck routes. The Germans could not stop the Allied armies in direct combat. They lacked the men, the tanks, the aircraft, but they could slow the advance by destroying infrastructure faster than it could be rebuilt, or so they believed. What German planners had not anticipated was the scale and speed of American engineering capability. The United States Army in Europe deployed over 300,000 engineer troops by early 1945. Combat engineers, attached to divisions, corps engineers handling larger construction projects, army engineers managing major infrastructure, communications zone engineers operating the logistics network from ports to front lines. These engineers operated with equipment that German forces could not match. American engineer units deployed bulldozers, graders, scrapers, cranes, pile drivers, air compressors, and specialized construction vehicles in quantities that seemed impossible to German observers. A single American engineer battalion might have more heavy equipment than an entire German engineer regiment. The equipment advantage was significant, but the organizational advantage was decisive. American engineers had developed systematic procedures for every type of construction task. Technical manuals specified exactly how to build bridges of various types, repair roads under different conditions, construct airfields on various terrain. These procedures had been refined through years of combat experience and were continuously updated based on lessons learned. When an American engineer unit encountered a destroyed bridge, they did not improvise a solution. They consulted documented procedures, selected the appropriate bridge type from standardized options, and assembled prefabricated components using established methods. The process was predictable, repeatable, and fast. German engineering, by contrast, still relied heavily on traditional craftsmanship. German engineers were well-trained and technically skilled, often more skilled individually than their American counterparts. But German procedures emphasized judgment and adaptation over standardization. Each project was approached somewhat uniquely based on conditions and available materials. This approach produced excellent results when time and resources were adequate. German military bridges were often more elegant and durable than American equivalents. German road construction met higher standards of finish and permanence. But under the pressure of mobile warfare, with time compressed and resources constrained, the German approach could not match American speed. The Remagen bridgehead illustrated these dynamics perfectly. On March 7, 1945, elements of the 9th Armored Division had captured the Ludendorff Bridge at Remagen intact, the only standing bridge across the Rhine in German hands. American forces poured across before German demolition charges could bring the structure down. The capture was a strategic windfall, but also a logistics nightmare. The bridge was damaged, weakened by partial detonation of German explosives. It could handle light vehicles but not heavy tanks or sustained traffic. Meanwhile, every American unit that could reach Remagen was rushing to cross, creating massive congestion on approach roads, never designed for such volume. German forces recognized the threat immediately. Artillery units redirected fire to the bridge and its approaches. The Luftwaffe, nearly destroyed by this point in the war, scraped together aircraft for bombing attacks. German engineers worked frantically to find ways to destroy the structure that American forces now controlled. American engineers faced a race against time and German firepower. They had to repair the bridge, strengthen it for heavier traffic, build additional crossing capacity, improve approach roads, establish supply depots, construct defensive positions, and do all of this while under constant artillery fire and air attack. The first priority was additional bridge capacity. The Ludendorff Bridge could not handle the traffic volume required to sustain major operations east of the Rhine. American engineers began constructing tactical bridges immediately, working through the night of March 7th and into the following days. By March 11th, engineers had completed a treadway bridge capable of carrying tanks across the Rhine. By March 17th, they had finished a heavy pontoon bridge that could handle any vehicle in the American inventory. Additional bridges followed in rapid succession. Within 10 days of the initial crossing, American engineers had constructed multiple bridges across the Rhine at Remagen, transforming a single captured structure into a major crossing complex. The speed was remarkable. Each bridge required hundreds of tons of material, thousands of man-hours of labor, precise assembly of standardized components. American engineers accomplished this while under fire, working around the clock, improvising solutions to problems that arose continuously. German observers were stunned by the pace of construction. A German officer captured near Remagen in mid-March later recalled his disbelief when interrogators described the bridges American engineers had built. He had expected one or two tactical bridges, temporary structures that would take weeks to erect. The reality of multiple permanent capacity bridges completed in days seemed impossible. But bridges were only part of the engineering challenge at Remagen. The roads leading to and from the bridgehead were equally critical and equally problematic. The road network on both sides of the Rhine in the Remagen sector had been designed for local traffic, not military logistics. Narrow roads wound through villages and up steep hillsides. Intersections were tight. Surfaces were often unpaved or poorly maintained. The roads could handle dozens of vehicles per hour. American operations required them to handle thousands. German forces had systematically damaged these roads during their retreat. Bridges over streams were demolished. Culverts were destroyed. Mines were planted at intersections and along shoulders. Artillery continued to crater the roads even after American forces occupied the area. American engineers attacked this problem with characteristic energy and systematic organization. They designated main supply routes and assigned engineer units to maintain specific road sections. Repair crews operated continuously, filling craters as they appeared, replacing destroyed culverts, clearing mines, improving surfaces. But repair was not enough. The existing roads simply could not handle required traffic volumes regardless of condition. American engineers had to build new roads, create bypasses around bottlenecks, widen narrow sections, straighten dangerous curves. They had to transform a local road network into a military highway system, and they had to do it while combat operations continued and enemy fire interdicted their work. The scale of road construction at Remagen illustrated American engineering capability at its most impressive. In the 2 weeks following the initial crossing, American engineers constructed over 160 kilometers of new road. Not repaired roads, new roads. Cut through terrain, graded, surfaced, ready for heavy military traffic. 160 kilometers in 14 days, more than 11 kilometers of new road per day on average. The pace was unprecedented in military history. German engineers who learned of these figures after the war struggled to comprehend them. German road construction standards called for extensive surveying, careful route selection, thorough preparation of roadbed, multiple layers of properly compacted material, finished surfaces meeting exacting specifications. Building 11 kilometers of road per day using German methods was physically impossible with any reasonable allocation of resources. American engineers achieved this pace through systematic application of mechanization, standardization, and simplified procedures. They did not build roads to German standards. They built roads that worked. The process began with route selection. American engineer officers surveyed terrain quickly, selecting routes that minimized earthwork requirements while meeting operational needs. They did not seek optimal routes. They sought adequate routes that could be constructed rapidly. Once routes were selected, bulldozers cleared vegetation and obstacles. American engineer battalions deployed bulldozers in quantities German units could not match. A single American engineer battalion might operate 12 to 20 bulldozers simultaneously on different sections of a road project. German engineer battalions often had 2 or 3 bulldozers total, sometimes none. The bulldozers pushed aside topsoil and vegetation, creating rough road traces. Scrapers followed, moving earth to fill low spots and cut through high points. Graders smoothed the surface to acceptable tolerances. The entire process, from virgin terrain to passable road surface, could be accomplished in hours rather than days. Surfacing varied based on available materials and intended use. For routes carrying the heaviest traffic, engineers laid steel matting over prepared roadbed. The matting was prefabricated in standard sections that connected easily. A crew of 20 men could lay a kilometre of matting in under 4 hours. For secondary routes, engineers often used crushed rock or gravel spread over compacted earth. The surface was rougher than steel matting but adequate for lighter vehicles. Local materials could be used when available, reducing transportation requirements. American engineers also employed a technique called corduroy construction for roads through soft ground. Logs were laid perpendicular to the direction of travel, creating a stable surface over mud or marshy terrain. The technique was ancient, used by armies for centuries, but American engineers applied it at industrial scale, felling trees with power saws and laying corduroyed sections at rates that seemed impossible to observers accustomed to manual construction methods. The results were not pretty. American military roads built under combat, conditions looked crude compared to German equivalents. Surfaces were uneven, drainage was often inadequate, curves were sometimes sharper than ideal. But the roads worked, trucks could use them, supplies could move, operations could continue. German prisoners of war who saw these roads were often contemptuous of American construction quality. The craftsmanship was poor by German standards. The engineering was simplistic. Any German engineer could identify deficiencies. What these prisoners missed was the fundamental point. The roads existed. They had been built in days rather than weeks. They were carrying the traffic that sustained the Allied advance. Quality that enabled operations today mattered more than quality that would require weeks to achieve. This philosophical difference reflected deeper contrasts between American and German approaches to military engineering. German engineering emphasized permanence, precision, and craftsmanship. These values produced excellent results, under conditions where time and resources were adequate. American engineering emphasized speed, functionality, and systematic replication. These values produced adequate results under conditions where time was the critical constraint. In a war of movement, where success depended on sustaining rapid advances, the American approach proved superior. German forces could not retreat faster than American engineers could build roads to follow them. The Remagen bridgehead operations demonstrated this dynamic clearly, but similar patterns emerged across the entire Western Front in early 1945. Wherever Allied forces advanced, American engineers built the infrastructure that sustained their operations. Roads were constructed, bridges erected, airfields established, supply depots organized. The pace was relentless, the scale enormous. By the spring of 1945, American engineers were building or repairing an average of 30 kilometers of road per day across the European theater. They were erecting bridges at a rate of one every 4 hours. They were operating quarries, sawmills, and fabrication facilities that produced construction materials in quantities that seemed industrial rather than military. The engineering effort consumed enormous resources. American forces shipped hundreds of thousands of tons of construction materials to Europe monthly. Steel for bridges and matting, timber for construction, gravel and crushed stone for road surfaces, cement for permanent structures, prefabricated buildings for depots and hospitals. The logistics of supplying the engineers was itself a major undertaking, but the investment paid returns that justified the expense. Every road built, every bridge erected, every supply facility constructed contributed to the logistics capacity that sustained combat operations. The engineering effort did not win battles directly, but it enabled the battles to be fought by ensuring that supplies reached troops who needed them. German commanders recognized this reality with growing despair as 1945 progressed. They could inflict casualties on American forces. They could slow advances temporarily, but they could not stop the relentless reconstruction of infrastructure that sustained the Allied advance. German demolition teams destroyed bridges. American engineers built new ones. German artillery cratered roads. American engineers filled the craters. German mines blocked routes. American engineers cleared them. The mathematics were inexorable. German forces could destroy infrastructure faster than German forces could rebuild it. But American forces could rebuild infrastructure faster than German forces could destroy it. The advantage belonged to the side with superior engineering capacity, and that side was unmistakably American. A German engineer officer captured near the Rhine in late March 1945 summarized this realization in interrogation. He described watching American engineers work on a road section his unit had mined and cratered the previous day. The Germans had spent 4 hours placing demolitions carefully, maximizing damage to the road surface and underlying structure. American engineers had the road open again in 90 minutes. The officer had expected his demolition work to delay American forces for at least 2 days. That was the time German engineers would have required to repair comparable damage using German methods and equipment. The 90-minute American repair seemed impossible. Yet there it was, trucks rolling over a road surface that German engineers would still be surveying. This officer's experience illustrated a broader pattern. German commanders consistently underestimated American engineering capability. Their estimates of how long demolitions would delay Allied forces were based on German construction rates, German equipment availability, German procedural approaches. American capabilities exceeded these estimates by factors of 3 to 5, sometimes more. The miscalculation had strategic consequences. German defensive plans that assumed certain delays from infrastructure destruction proved inadequate when American engineers eliminated those delays faster than expected. Defensive positions that should have had days to prepare found themselves under attack in hours. Retreat routes that should have remained open closed earlier than planned because American advances outpaced German expectations. The spring of 1945 brought these dynamics to their ultimate conclusion. American forces crossed the Rhine at multiple points following Remagen. Each crossing required massive engineering support. Each advance into Germany encountered destroyed infrastructure that American engineers rebuilt at speeds that continued to astonish German observers. The final campaigns of the war in Europe became as much engineering operations as combat operations. American forces advanced not primarily because they won battles, though they did win battles, but because they could sustain advances through superior logistics enabled by superior engineering. The roads American engineers built carried the supplies that fueled the tanks that ended the war. The engineering achievement at Remagen represented more than technical capability. It revealed a fundamental difference in how American and German forces approached modern warfare. German military doctrine had always emphasized the decisive battle, concentration of force at critical points, superior tactics executed by well-trained soldiers. The Wehrmacht sought to win through operational brilliance, destroying enemy forces through maneuver and firepower. Logistics existed to support operations, but logistics was never central to German strategic thinking. American doctrine evolved differently. The United States entered the war understanding that its advantages lay not in tactical excellence, but in industrial capacity and organizational efficiency. American planners recognized that sustained operations depended on sustained logistics, and sustained logistics depended on infrastructure. This recognition shaped everything about American military engineering. Engineer units received priority for equipment and personnel. Training programs emphasized speed and standardization over craftsmanship. Procedures were developed, documented, and continuously refined based on combat experience. The entire engineering effort was organized as an industrial system rather than a collection of skilled tradesmen. The results spoke in statistics that German commanders found almost incomprehensible. During the final year of the war in Europe, American engineers constructed over 8,000 kilometers of new roads. They built more than 3,000 bridges. They repaired or improved an additional 12,000 kilometers of existing roads. They established hundreds of supply depots, dozens of airfields, countless smaller facilities. This construction occurred while combat operations continued. Engineers worked under fire, in adverse weather, with inadequate sleep, on terrain that enemy forces had systematically damaged. They accomplished construction rates that peacetime civilian contractors would have considered aggressive scheduling. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The contrast with German engineering capacity grew starker as the war progressed. German engineer units, never as well equipped as American equivalents, lost equipment steadily to combat attrition and Allied air attacks. Replacement equipment was not available. German industry, battered by strategic bombing and starved of raw materials, could not produce bulldozers and graders in adequate quantities. By early 1945, many German engineer units had essentially no heavy equipment. They relied on hand tools and manual labor for construction tasks. Work that American engineers accomplished in hours with bulldozers required German engineers days with shovels. The disparity was not a matter of skill or effort. German engineers worked as hard as American engineers, often harder given their desperate circumstances. The disparity was purely a matter of resources and organization. German commanders recognized this reality but could do nothing to change it. Field Marshal Walter Model, commanding Army Group B in the final months of the war, reportedly described American engineering capability as more dangerous than American tanks. Tanks could be destroyed or evaded. Engineering capability could not be stopped. Every road American engineers built brought more supplies forward. Every bridge erected expanded American operational reach. The engineering effort was relentless, inexorable, impossible to counter through military action. Model's observation captured a truth that German strategic planning had never adequately addressed. Modern mechanized warfare consumed supplies at rates that strained any logistics system. The side that could move supplies more efficiently gained advantages that accumulated over time. Superior logistics did not win individual battles, but it determined who could sustain operations long enough to win the war. American engineers built the infrastructure that enabled American logistics superiority. Their roads carried the trucks that delivered the fuel that powered the tanks that broke German resistance. The chain of causation was clear to anyone who examined it honestly. German prisoners of war who witnessed American engineering operations often described experiencing a moment of clarity about why Germany was losing. The realization came not from seeing American tanks or aircraft, weapons Germany could produce in roughly comparable quality. The realization came from seeing American engineers build a road in 3 days that German engineers would have required 3 weeks to construct. That disparity in construction speed translated directly into disparity in operational tempo. American forces could advance faster because they could build the infrastructure to sustain faster advances. German forces could not match this pace, regardless of tactical skill, because they could not match American engineering capability. One German engineer officer, interrogated after his capture near the Rhine, provided an assessment that summarized the broader situation. He had commanded a bridge construction company in the German army since 1942. His men were experienced, well-trained, capable of excellent work under difficult conditions, but they had almost no equipment remaining. Their last bulldozer had been destroyed by air attack in February. Their trucks were worn out, lacking spare parts, consuming precious fuel. When his unit was ordered to construct a bridge across a stream to support defensive operations, they had to fell trees by hand, shape timbers with hand tools, move materials by muscle power. The bridge took 4 days to complete. It was a good bridge, well constructed, capable of bearing heavy loads. American engineers built a comparable bridge across the same stream, 3 kilometers away. The American bridge was completed in 7 hours. The German officer watched the American construction through binoculars. He saw bulldozers clearing approaches in minutes. He saw cranes lifting prefabricated bridge sections into place. He saw the systematic efficiency of men following established procedures with adequate equipment. His own men, working with hand tools, could not compete. That moment, he told interrogators, was when he understood that Germany had lost the war, not because German soldiers were less brave or German officers less skilled. Germany lost because it could not match the industrial and organizational capacity that American forces brought to every aspect of military operations, including the mundane but critical task of building roads and bridges. The engineering achievements of the Remagen campaign demonstrated American capability at its peak: 160 kilometers of new road in 14 days. Multiple bridges across the Rhine completed in times that seemed impossible to German observers. Supply routes established, maintained, and expanded faster than German forces could disrupt them. These achievements did not result from American engineers being inherently superior as individuals. German engineers were often more thoroughly trained, more experienced with certain construction techniques, more capable of elegant solutions to engineering problems. American engineers were frequently criticized by their own officers for sloppy work, inadequate attention to detail, preference for expedient solutions over proper engineering. But American engineers had equipment. They had standardized procedures. They had organizational systems that enabled systematic replication of proven methods. They had the industrial backing of an economy that could produce construction materials and equipment in quantities German industry could not approach. The equipment mattered enormously. A single American bulldozer accomplished work that would require dozens of German soldiers with hand tools. Multiply that advantage across hundreds of bulldozers, add graders and scrapers and cranes and specialized vehicles, and the cumulative capability became overwhelming. The standardization mattered equally. When an American engineer unit needed to build a bridge, they selected from standardized designs, assembled prefabricated components, followed documented procedures. They did not need to design a bridge from scratch or fabricate components in the field. The system provided everything required for rapid construction. German engineering retained more traditional characteristics. German engineers designed solutions for specific situations, fabricated components as needed, relied on experience and judgment rather than standardized procedures. This approach produced excellent results when time permitted. Under the time pressure of mobile warfare, it could not match American speed. The final weeks of the war brought these dynamics to their conclusion. American forces advanced across Germany on roads that American engineers built or repaired. Supplies flowed forward on routes that American engineers maintained. The logistics system that sustained operations depended entirely on engineering capability, and that capability proved equal to every demand. German resistance collapsed not primarily because German forces lost battles, though they did lose battles. German resistance collapsed because German forces could not be supplied, could not move, could not maintain defensive positions against an enemy whose logistics functioned efficiently, while German logistics disintegrated. American engineers had built the foundation of victory. Their roads and bridges were as important as tanks and aircraft in determining the war's outcome. The 160 kilometers of road constructed in 14 days at Remagen symbolized a capability that German forces could not match and could not stop. When Germany surrendered in May 1945, American engineers immediately shifted to occupation support and reconstruction tasks. The same organizational systems, standardized procedures, and industrial backing that had enabled wartime construction now enabled recovery of shattered infrastructure. Roads were rebuilt, bridges were restored. The logistics network that had sustained military operations began sustaining civilian recovery. German engineers who survived the war studied American methods with intense interest. Many recognized that German engineering traditions, while producing excellent individual results, could not match American systematic efficiency under conditions requiring rapid large-scale construction. The lessons learned would influence German engineering practice for decades afterward. The road-building achievement at Remagen became a case study in military engineering schools. The statistics were remarkable. 160 kilometers of new road in 14 days, 11 kilometers per day average, construction rates that seemed impossible until American engineers demonstrated they were achievable through mechanization, standardization, and systematic organization. German military planners had believed that infrastructure destruction would slow Allied advances significantly. They had calculated delays based on German construction capabilities. They had been wrong because they failed to understand how fundamentally American engineering differed from their own traditions. The roads American engineers built carried the supplies that ended the war. The bridges they erected enabled the advances that conquered Germany. Their achievement was not glamorous. It did not produce heroes celebrated in newspapers or medals awarded in ceremonies, but it was essential. Without those roads, tanks would have stopped for lack of fuel. Artillery would have fallen silent for lack of ammunition. Soldiers would have gone hungry for lack of rations. The entire mechanism of modern warfare depended on logistics, and logistics depended on infrastructure that engineers built under impossible conditions at impossible speeds. The German officers who said it could not be done were not fools. They were professionals applying reasonable assumptions based on their experience. They simply did not understand what American industrial organization and systematic engineering could accomplish. 160 kilometers of road in 14 days, the achievement that could not be done, done anyway. the foundation of victory laid in gravel and steel matting across the fields of Germany. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.